Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Okay, very nice. Let's move on to the second question. So we need to find the range of values of y for which x is real for this equation. Okay, we will rewrite this equation first. Y equals to 2x minus 3 over x squared minus 8x plus 12. Okay, now we are going to move the denominator on to the left hand side. So we will get this equation. Yx squared minus 8yx plus 12y equals to 2x minus 3. Okay, then we are going to factorize the equation again and rearrange them to make them look nicer. So we have successfully formed a quadratic equation in terms of x, where a equals to y, b equals to minus 8y plus 2, and c equals to 12y plus 3. And to obtain real solution, right, we know that b squared must be larger than 4ac. So we can rewrite the equation as 8y plus 2 squared is larger or equal to 4y times 12y plus 3. We can rearrange this equation again and we will get 64y squared plus 32y plus 4 is larger or equal to 48y squared plus 12y. And we further rearrange them and divide by 4, we will get 4y squared plus 5y plus 1 is larger or equal to 0. And next we are going to factorize this equation and we will get 4y plus 1 times y plus 1 is larger or equals to 0, and we know that y is smaller or equal to minus 1, or y is larger or equal to negative 1 over 4. This is the range for all real solutions. We also need to note that negative 1 and negative 1 over 4 are the respective y coordinates of the maximum and minimum point of this curve. This is a fairly easy way to obtain the stationary point without having to use the dy dx. So now you just know that y equals to minus 1 and you substitute it into the original equation, and we can do this computation and find out what is the x value. And when y equals to 1, once we finish this computation, we know that x equals to 3. The maximum point of this curve is 3 minus 1. And when y equals to minus 1 over 4, we perform the same computation. Okay? And we found that x is equals to 0. And hence the minimum point is 0, minus 1 over 4. Alright, now we are going to sketch this graph. Y equals to 4x squared minus 3x over x squared plus 1. Let's start with the identity. So we look at the numerator and the denominator of this equation and we realize that they have the same power. So we will use the identity that we have learned just now and transform it into a new equation. What we are trying to do here is to make the numerator the multiple of the denominator. So what's the similarity here? So take a look at the denominator, we have x squared plus 1, and the numerator we have 4x squared. And to make it into a multiple of it, so we need to make 4x squared plus 4. And since we add a 4, we have to minus back the 4, and we write the minus 3x, and we get this equation. And then after that, we can factorize the 4 out so that we can cancel off the x squared plus 1. Okay, so once we cancel out, we have a clean equation with the numerator being 1 power lower than the denominator. Next, we are going to find the asymptotes. So how do we find the asymptotes? First of all, we let the denominator equals to 0. So in this case, it's x squared plus 1 equals to 0. So now we rearrange the equation. X squared equals to minus 1. And we know that the square root of 1 is an imaginary number. So we don't have any vertical asymptote in this case. For the other asymptote, we are going to look at the non-fractional part of the identity equation. So in this case, it's 4. So we know that the other asymptote is y equals to 4. Third step is to look at the behavior of the graph. So how do we look at the behavior? Again, we will look at the positive infinity and the negative infinity. So when x approaches negative infinity, now we substitute the negative infinity into the equation, and we will obtain a y value which is small and positive. So we say that the curve approach from the above. When x approaches positive infinity, y is small and negative. Hence we say that it approached from below. Okay, let's look at more detailed explanation. We will substitute the infinity into the x, which is the fractional part of this equation. So before that, we know that 4 is the asymptote of the whole equation. 3 times negative infinity is a negative infinity over a negative infinity squared is a big infinity but positive. And negative times negative is positive, so we say it approached from the above. And then now we substitute positive infinity instead, and we will get a negative number, so approach from below, as you can see on the graph that I've drawn. That's all for the behavior. Now we will move on to find the special points and the stationary points. So this time we will not be doing dy dx, but we will rewrite the equation. Y equals to 4x squared minus 3x over x squared plus 1, and then we move the denominator to the other side. So we will get a new equation, which is y minus 4 times x squared plus 3x plus y equals to 0. We will form a quadratic equation in terms of x. So a is y minus 4, b is 3, and c is y. And to find real solutions, we know that b squared must be larger or equal to 4ac. So substituting a, b, c into the equation, then we know that 9 is larger or equal to 4 times y minus 4 times y. And we rearrange the equation, and we will get 4y squared minus 16y minus 9 is less than or equal to 0. Now I'm going to factorize the equation until I get a range of values of y which are real, and at the same time I can deduce the stationary point for the y values. So we can deduce that the range of y is between negative 1 over 2 and 9 over 2. So the stationary point y values are 9 over 2 and negative 1 over 2. Now substitute y equals to negative 1 over 2 into the equation, and we found out that x equals to 1 over 3. So the turning point is 1 over 3 and minus 1 over 2. When y equals to 9 over 2, we substitute it into the equation again, and we realize that x equals to negative 3. So negative 3, 9 over 2 is the second turning point. We have all the information that we need, and now we can sketch the graph. So the first step is to draw out the asymptote, which in this case is y equals to 4. So we draw dotted lines y equals to 4 in our graph. The second step is to find the behavior, and we have know what the behaviors are at negative and positive infinity. So at negative infinity, the graph will approach from the above, and for negative infinity, the graph will approach from below. Now, we will label the two stationary points that we have found just now, which are 103, negative 102, and negative 3, 902. The final step is to join all the dots together, and we will get a perfect smooth curve. Finally is the appendix that I've prepared. I've written down all the possible equations that might come out in the exam, and also what kind of curve that you are going to expect to draw during the exam when you see this kind of curve. So just look at them as a reference. There's no need to memorize them, so just have fun looking at it. I would also like to point out that there's something special here. This px plus q, which is the identity of ax squared plus bx plus c over ex plus f, is a rather special type of asymptote. It's known as the oblique asymptote. And this oblique asymptote is just basically a slanted straight line, which you can see how I will draw it in the graph later.
that's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.